is October 3rd, 2025. The Mars night is quiet, too quiet. Perseverance's navigation camera blinks through a stack of 20 frames, scanning the crimson sky for a single predicted visitor. 3I Atlas, humanity's third verified interstellar object. For weeks, scientists and amateurs alike have waited for this exact moment, when an object from another star system would brush past Mars, closer than any before. But something is wrong. The transmission feed flickers. NASA's data servers go dark. 15,000 staff are suddenly furloughed as a government shutdown freezes every public update. All that remains is a single faint smudge, exactly where 3I Atlas should be. Across X and Reddit, astronomers draw red circles around the blurred streak, arguing whether it's a comet, a probe, or something built. As the silence deepens, speculation explodes. Why did the data vanish the moment the object appeared? What did the latest images actually capture? Tonight, the world waits in the dark, staring at a 20-frame mystery from Mars. And for the first time since Oumuamua, we may be watching the universe look back. When the Discovery Alert first hit NASA's Minor Planet Center months ago, astronomers were skeptical. 3I Atlas wasn't just another comet. It was moving too fast, cutting through the solar system on a hyperbolic path, never to return. Its speed, over 60 kilometers per second, marked it as interstellar, a traveler from beyond our sun's influence. But almost immediately, the data refused to behave. Typical comets flare as they approach the sun, releasing dust and gas in predictable arcs. 3I Atlas, however, remained eerily stable, its brightness constant, its coma strangely asymmetric. Instead of a trailing tail pushed away by solar wind, the faint halo seemed to point toward the sun itself. For veteran observers, it defied every model in the textbooks. Then came the first radar returns, echoes inconsistent with a loose, icy body. Spectral signatures hinted at nickel without iron, a metallic fingerprint nature rarely produces alone. Planetary scientists debated whether it was an industrial residue, an ancient alloy, or simply an uncalibrated reading. The disagreement fractured the community. Some called it noise, others whispered about engineering. Amid the noise, the biggest question emerged. Why does every observation contradict what we know about comets? The object's orbit hugged the ecliptic plane almost perfectly, threading near Venus, Mars, and, in a few months, Jupiter, all within a single pass. That kind of alignment would be statistically improbable for a random interstellar wanderer. By late September, predictions placed its closest Mars approach on October 3rd, exactly the moment Perseverance recorded that faint, controversial smudge. Yet the coincidence felt too precise, the timing too perfect. Scientists insisted on patience. Raw data still had to be processed, cross-checked, peer-reviewed. But patience is a rare commodity on the internet. While NASA's analysts waited for calibration, amateur astronomers stacked images and overlaid trajectories. The blur lined up exactly with the projected position. Every new pixel deepened the mystery. Was this simply an elongated rock tumbling through the void? Or something deliberately passing by Mars, testing its cameras, watching us watch it? The more the numbers were checked, the less they made sense. And the more silence came from NASA, the louder the doubt became. By the first week of October, the Perseverance image stack had become a battlefield of interpretation. In one corner stood the mainstream researchers, those who had seen enough cosmic noise to recognize a coincidence when they saw one. In the other, a growing circle of independent scientists and data analysts argued that coincidence alone could not explain what was unfolding. At the Jet Propulsion Laboratory in Pasadena, a skeleton crew of engineers worked through the shutdown, manually checking the Deep Space Network logs. Raw telemetry kept arriving from Mars orbiters, MRO, Mars Express, and the Trace Gas Orbiter, but only fragments were being decoded. Automated systems flagged multiple frames for review, pointing errors, anomalous reflections, pixel compression mismatches. None could be cleared until the furloughed teams returned. Still, some data slipped through. What they found was strange enough to divide entire departments. The first anomaly was the object's mass. Based on astrometric drift, its acceleration was nearly zero. Even as solar radiation should have nudged it off course, The deviation remained less than 15 meters per day squared, practically unmovable for an icy nucleus. That implied density beyond anything expected from a comet. The second anomaly came from Hubble's early imaging. The coma, instead of streaming away from the sun, extended toward it, as if something within 3I Atlas was producing thrust against solar pressure. Some suggested outgassing jets aimed sunward, a rare but not impossible geometry. Others quietly wondered if it was deliberate propulsion. The third anomaly emerged from spectroscopy. The Very Large Telescope in Chile detected prominent nickel emission lines, but virtually no iron. In normal comets, nickel and iron travel together, forged in ancient stars. To see nickel alone raised eyebrows. It was the kind of ratio one might expect from industrial processing, not natural formation. Polarimetry added a fourth anomaly, negative polarization at phase angles that defied catalog behavior. No known comet or asteroid matched the pattern. And then came the orbit itself. The fifth anomaly. It wasn't just interstellar, it was perfectly aligned with the ecliptic, threading near multiple planets as if following a route rather than a random path. Analysts at ESA's Darmstadt Center tried to simulate plausible capture scenarios, but every model required initial conditions too fine-tuned to occur by chance. When they ran Monte Carlo simulations, fewer than 1 in a million trajectories produced the same multi-planet conjunctions observed for 3I Atlas. As these results circulated, the debate turned personal. At a symposium live-streamed from Harvard, astrophysicist Avi Loeb called for open data, insisting that withholding imagery would only fuel suspicion. If the object is natural, he argued, sunlight and math will prove it. If it's not, silence will only delay the inevitable. Others pushed back, warning that premature claims could damage credibility and invite pseudoscience. But then a sixth anomaly surfaced. Radio analysts noticed that the projected path of 3I Atlas passed within 9 degrees of the legendary 1977 WOW signal, an eerie echo from humanity's first unexplained interstellar transmission. SETI veterans dismissed it as trivia, but the alignment revived questions long dormant. For the skeptics, all of this amounted to a string of coincidences stacked like dominoes, each intriguing, none decisive. For believers, it was a pattern hiding in plain sight. And for NASA, it was a communications nightmare unfolding during a government freeze, when even press officers were locked out of their systems. Every hour, the silence stretched longer. Meanwhile, Discord servers filled the gap, with citizen scientists tracking deep space network downlinks and cross-referencing ESA past schedules. The data trail had turned into a global puzzle hunt. One user overlaid the Perseverance smudge with older comet images and noted that no known comet exhibited such perfect linearity. Another found a faint metallic reflection pattern, consistent with something smooth, cylindrical. No one could prove it, yet no one could dismiss it either. In the absence of verified imagery, speculation became the default language of discovery. The universe had offered humanity a new mystery, but the only agency capable of answering it had gone dark. Tonight isn't just another night on Mars. It's the night every telescope, dish, and rover across 3 agencies was scheduled to look up at once. October 3rd marks the precise midpoint between 3I Atlas's Mars flyby and its upcoming perihelion at 1.36 astronomical units. For planetary scientists, this is the window when physics either proves itself or rewrites itself. Under normal conditions, this would be a celebration. Data teams at JPL, ESA's ESO-C Center in Darmstadt, and the Japanese Space Agency's Sagamihara complex would compare raw packets in real time, correcting parallax, aligning spectra, and cross-verifying each frame. Instead, most terminals tonight display a single word: furloughed. 15,000 scientists, data analysts, calibration engineers, even public information officers are offline, waiting for Congress to sign a budget resolution. With NASA in partial shutdown, only a handful of essential operators remain, maintaining ISS communications and Artemis systems. On Mars, Perseverance and the orbiters continue their routines, capturing images and telemetry. But the pipeline that turns bits into clarity has slowed to a crawl. Every new dataset goes into a digital backlog, encrypted and unreviewed. It's a silence that feels engineered. For those watching from the outside, the blackout is perfect timing. A verified interstellar object passes within the camera range of 4 orbiters, and not one high-resolution image reaches the public. On social media, the hashtags spiral, O Atlas cover up, Jiao signal from Mars, Jiao let NASA speak. Each unanswered comment adds oxygen to the fire. Yet behind closed doors, in the dim light of backup servers, a few small teams are still working. ESA's Mars Express imaging team confirms successful telemetry captures at 3.15 UTC, but delays publication pending cross-agency validation. The Trace Gas Orbiter detects unusual polarization angles in the dust halo, consistent with earlier ground-based anomalies. And at JPL, a backup feed from the Deep Space Network shows a faint but regular spike, 22 seconds apart, embedded in the raw signal from Mars orbit. Engineers label it possible compression noise. Others aren't so sure. As midnight passes, astrophysicist Avi Loeb appears on a livestream, his voice calm but insistent. If this is nothing, release the data. If it's something, the world deserves transparency. Science dies in silence. The line goes viral within minutes, but official channels remain frozen. ESA's spokesperson reiterates that all Mars imagery is under embargo until full analysis resumes. The US side offers no statement at all. Why does it matter? Because this is the moment when discovery meets accountability. If 3I Atlas turns out to be natural, every anomaly, from nickel chemistry to sunward coma, becomes a new clue about how matter forms between stars. But if any one of these outliers hints at control, regular pulses, consistent alignment, thrust-like acceleration, then humanity's definition of natural collapses overnight. The implications stretch far beyond astronomy. A verified non-natural trajectory would trigger the first formal application of the First Contact Protocol, transferring responsibility from NASA to international oversight under the UN Office for Outer Space Affairs. Funding, politics, and secrecy would collide. Suddenly, the question isn't what is it, but who decides who gets to know. For now, though, everything depends on tonight's unprocessed images sitting in NASA's servers, frozen mid-transmission, waiting for someone to press resume. Every frame, every pixel, every unexplained spike could rewrite the story of the solar system. But until the lights come back on, the only certainty is uncertainty itself. As the night deepens, speculation organizes itself into 3 distinct camps, 3 futures balanced on the edge of a signal. Scientists call them scenarios, but for the millions following the story, they sound more like plot lines in a cosmic thriller. Scenario 1, the safe explanation. In this version, everything has a mundane cause. The apparent anomalies, the nickel lines, the sunward coma, the near-zero drift, all stem from calibration errors, cosmic ray interference, and incomplete data processing during the shutdown. Once the full pipeline comes back online, new frames will reveal a standard carbon dioxide-rich comet, whose rotation axis happens to align with the Sun. The faint pulses seen in Deep Space Network telemetry, merely packet collisions inside a half-staffed data relay, a technical hiccup mistaken for the extraordinary. This scenario comforts those who trust in physics as it stands. It's the voice of experience reminding the world that every great mystery begins as a bug in the code. If true, 3I Atlas will quietly join the long list of misinterpreted phenomena, another reminder that patience is the first rule of science. Scenario 2, the dangerous one. Here, the anomalies are real, but natural in origin, and potentially catastrophic in effect. If the object's density truly exceeds known cometary values, it could be a fragment of super-dense interstellar debris, nickel-rich, magnetic, and massive enough to perturb small-body orbits as it passes through. A sunward jet could indicate volatile outbursts, capable of unpredictable thrust. And if the trajectory intersects Mars's orbital path too closely, even a dust grain impact could threaten orbiting hardware. In this timeline, mission planners worry less about alien engineering and more about kinetic risk. A dense, fast-moving nucleus crossing planetary lanes at 60+ kilometers per second carries energy on the scale of nuclear weapons. A single collision with a dormant satellite could create a debris cloud around Mars, jeopardizing decades of exploration. To avert panic, agencies would classify the data until the path stabilizes. silence becomes containment. Scenario 3, the extreme possibility. This is the scenario everyone whispers about, but few dare to print. It starts with the assumption that coincidences are not coincidences, that the ecliptic plane alignment, the nickel-heavy signature, and the timed pulses are connected. In this view, 3I Atlas isn't a random visitor, but a constructed probe, perhaps damaged, perhaps ancient, using the sun's gravity for a controlled slingshot. The regular 22-second spike observed in Mars telemetry might not be noise at all, but a form of directional signaling, a repeating handshake, waiting for acknowledgement. Its coma could be an engineered shroud, layers of volatile ice designed to mask a metallic core. The near-zero acceleration, once seen as static, would make sense if the object compensates actively, maintaining course with microthrusts invisible to current instruments. Those favoring this view point to the wow, signal coincidence as more than poetic. They suggest that the transmission in 1977 and this object's path in 2025 may be data points in a single long-arc experiment, a test of whether intelligence here can notice a pattern lasting half a century. Skeptics dismiss it all as fantasy, citing Bayesian probabilities that keep the odds of an engineered origin below 1 in a million. Yet, probability, as history often reminds us, does not equal impossibility. In 2017, the odds of seeing even one interstellar object were considered microscopic, until Oumuamua appeared. Whichever scenario proves true, the stakes are enormous. If scenario 1 wins, humanity learns humility. The cosmos remains strange, but physics still holds. If scenario 2 unfolds, we face a tangible threat, a reminder that space is not empty and planetary defense is not optional. If scenario 3 becomes real, every scientific institution on Earth will confront the same existential question. What do we say to the stars once they've spoken first? For now, all three remain balanced on incomplete data, awaiting verification from the next observation windows. October 29th for perihelion, November 2nd when the JUICE spacecraft begins its deep space watch, and December 19th for Earth-based reacquisition. Between those dates lies a silence that could define a century. If 3I Atlas is merely a comet, its story will fade quietly into the archives. But if even one of its anomalies holds, if one number survives peer review unchanged, the repercussions will echo for decades. Because what's at stake is not just a mystery in the Martian sky, but the foundation of how humanity understands and manages discovery itself. For NASA, the first consequence is trust. A blackout during a global moment of curiosity has already eroded public confidence. In an age when every smartphone can image the heavens, the idea that data from a taxpayer-funded mission could vanish behind bureaucratic silence feels archaic. If the delayed release proves innocent, transparency will become a new scientific doctrine. If it hides more, that silence may define the decade. Beyond institutions, the second consequence cuts deeper: the philosophy of evidence. For centuries, science has thrived on reproducibility, what can be seen, measured, and repeated. But interstellar objects are one-time visitors. Each pass offers a single chance to observe, then it's gone forever. If 3I Atlas carries signals or chemistry we can't replicate, the standard of proof itself will need rewriting. Absence of repeatability, as one physicist put it, cannot mean absence of truth. A third consequence is ethical. Should the data suggest non-natural origin, who owns that discovery? The nation that first processed the image, the consortium that built the telescope, or the entire species whose sky it crossed? The Outer Space Treaty of 1967 declares space the province of all humankind, yet no clause covers intelligent artifacts. If 3I Atlas were confirmed as technological, global politics would pivot overnight, from competing to explore space to competing to interpret it. Even the optimistic outcomes are profound. If this object proves to be a natural messenger from another star system, it would still redefine our understanding of how planetary debris travels between worlds. Samples or spectra could reveal elements never found within the solar system, new isotopes, new chemistry, maybe even prebiotic compounds that seeded life elsewhere. The idea of panspermia, long dismissed as speculation, might suddenly gain a data point. And then comes the human consequence. Readiness. For generations, humanity has looked outward expecting mystery, but not responsibility. If 3I Atlas forces us to confront the possibility that intelligence isn't unique, or that someone else once built and lost what we now find, it will change not just science, but culture, religion, and education. Every child learning the night sky would grow up under a different question. Not, are we alone? But why were we the last to know? Whether natural or engineered, this object will not stay silent forever. Its path already ensures reacquisition in December, and by then, the debate will no longer belong to scientists alone. Governments, ethicists, and billions of ordinary people will weigh in. The universe has thrown us a test, not of technology, but of humility. Behind every dataset, behind every line of code and silent telemetry packet are people, ordinary, exhausted, and often invisible. While the world scrolls through hashtags and speculation, a handful of engineers and astronomers are still awake in half-lit control rooms, watching blinking cursors that refuse to move. At Jet Propulsion Laboratory, one systems engineer named Rachel Kim sits in front of 3 monitors, each frozen on a line of incomplete telemetry from the Mars Reconnaissance Orbiter. She's been furloughed officially, but unofficially, she's here anyway, volunteering off the clock. If we wait for the paperwork, she whispers to a colleague over a mug of cold coffee, the data will rot. Thousands of miles away in Darmstadt, Germany, an ESA image processor named Luis Ortega writes custom scripts on his personal laptop, trying to cross-stitch partial frames from the trace gas orbiter into something coherent. His apartment window looks out at a cloudy sky, but his screen glows with a thin, pixelated arc, the faint halo of 3I Atlas. He knows it's incomplete, but it's enough to keep him typing. And scattered across the globe, amateurs are doing the same. In suburban garages, high school observatories, and mountain outposts, citizen scientists track the sky through open-source telescopes, feeding real-time positions into shared spreadsheets. A retired software engineer in Arizona recalibrates his deep sky camera nightly, comparing the Perseverance frame against every public ephemeris update. A group in Poland builds a web dashboard to synchronize JUICE observation schedules. They call it Project Silent Atlas. None of them are paid. None have security clearance. Yet together, they are keeping the story alive. People who can't stand silence where curiosity should speak. Even within NASA's frozen halls, some data custodians find quiet ways to act. An anonymous internal email circulates, "Integrity doesn't clock out." Small teams schedule after-hours data pulls, backing up unprocessed frames to offline storage to ensure nothing gets lost when systems reboot. No one knows if it's officially permitted, but no one asks. The mythology of exploration often celebrates rockets and discoveries, but rarely the patience, obsession, and stubborn humanity beneath it. The people staring into flickering screens tonight are driven by something older than institutions, the need to know. Whether they uncover a comet, a probe, or nothing at all, they remind us that science isn't an algorithm, it's a heartbeat. And somewhere between the red sands of Mars and the glowing monitors of Earth, that heartbeat continues, steady and human, waiting for the next signal to arrive. Dawn breaks on Earth, but Mars remains in darkness. Somewhere between both worlds, 3I Atlas continues its silent arc toward the sun, indifferent to the noise it left behind. On servers 500 million miles apart, fragments of data wait, unprocessed, unexplained, unresolved. When those images finally surface, whether tomorrow or months from now, they may show nothing more than a lopsided rock streaking through solar glare, or they may show something that refuses to fit any known category. Either way, the mystery has already done its work. It has reminded humanity that discovery isn't a moment of clarity, but a process of wonder, friction, and courage. In the quiet aftermath of speculation, a few truths stand unshaken. Science is not faith, it's the refusal to stop asking. The cosmos doesn't owe us certainty, only opportunity. And sometimes that opportunity arrives not as a revelation, but as a faint blur in a 20-frame image taken by a rover millions of miles away. As the world waits for the next data release, astronomers mark their calendars. October 29th for perihelion, November for the JUICE window, December 19th for Earth reacquisition. Each date, another door, another question. Somewhere in those months lies the answer, or the next mystery waiting to unfold. Perhaps 3I Atlas is just frozen gas, drifting where gravity dictates, or perhaps it is something else, a message, a relic, a test of how we handle the unknown. In the end, the question may matter less than the response, because when the universe whispers, the real measure of intelligence isn't how fast we decode it, but how carefully we listen. Tomorrow, the first new images could change everything, or nothing. But tonight, as Perseverance's cameras blink once more into the Martian sky, humanity stands exactly where it has always stood, between data and doubt, staring upward, waiting for the universe to speak again.